All right. So here we are. It is November 29th. Um, so I'm starting the video for that, obviously. Wow. Okay. Uh, so you're due now today. Wanted you to find the additive inverses, or in other words, the opposites of the following numbers. Okay. So additive inverse means they add to give you 0. That's actually the definition of additive inverse. So their signs are just different, but their numbers are the same. We're actually going to learn about multiplicative inverse later, but for now, we'll keep with additive inverse. So those two numbers just add to give you 0. So when we have 1, they gave you, it was 8. So the additive inverse would be the negative 8. 2, 1.5, additive inverse would be negative 1.5. Negative 16, additive inverse is 16. Negative 3/4, additive inverse is 3/4. Then for number 5, x, the additive inverse would be negative x. Okay? So that's all. That is just a quick review there that's going to actually help us out in our lesson today. Before we get to that, though, we are going to go over the homework here. Okay, so this is your homework from last night. If you were not here yesterday, if you did not do this for any reason, remember you are not just writing these down, okay? You should have tried this yourself last night. If you didn't get a chance for whatever reason, you're trying it yourself tonight or the following night. You are doing this. You are not just writing this down off my screen. If you are doing that, it does not count as a homework ever for you, okay? So they want you to write equivalent expressions by combining like terms. So remember, like terms are like A's and A's together, B's and B's together, regular numbers and regular numbers. We're not taking an A and a B and making them an AB. No, we're not doing that, okay? So we have 3A plus 5A here. So all you're doing is you're adding the 3 and the 5 together to get 8, and A stays an A. So, okay, so 2, 8 minus 4 gives you 4, B stays a B. Okay, although we're doing 8B minus 4B, we're not getting rid of that B. So this would be like writing B out 8 times and writing B out 4 times and taking them away. Okay, and we have 5C plus 4C plus 1C. If the number is not written, it's always 1. So 4 plus 5 is 9, plus 1 gives you 10. We keep C. All right, so 4. I'm going to start doing some boxes and circles here. So I'm boxing in the A's. So when I box 3A, then I box plus 5A. You always want that symbol before the number if there is one, okay? So what we're going to do, 3 plus 5 gives us 8. A stays an A. And then we carry down our plus 6 because there's nothing else like it, okay? So 5, 8B. And then you have minus 4B. So we're just do 8 minus 4. Gives us 4. And we keep our B. Our plus 8 carries all the way down. All right, 6. They're all C's. So 5C minus 4C plus 1C. You can add this up whichever way you please. 5C and 1C over here give you 6C. And then you can subtract your 4C. Doesn't really matter. In the end, there's 2 C's. Okay, 7. You have 3A plus 5A. So those are your like terms. 3 plus 5 is 8. We keep our A. From there, you have 6. And then a minus 2. So I circled the plus 6 and the minus 2 because those are like terms. So I kind of group them by a shape. So 6 minus 2 gives us a positive 4. Okay, and that's it from there because these are not like terms after that. 8B minus 4B, so it gives you 4B. 8 minus 3 is going to give you a positive 5. Okay, if you need to use your calculator for any of this, especially if there's a lot of negative stuff happening, that's fine. You would type 8 minus 4 in or 8 minus 3 in. That's the part you can type in, not the letters. Okay? So 9, they're all C's. So I'm going to add my positive C's together and get 6C. And then my negatives get negative 7C. then 6 minus 7. If you keep change, 6 plus a negative 7 is a negative 1c, or just negative c. Those are the same. Okay. So number 10, Jack got the expression 7x plus 1 and then wrote his answer as 1 plus 7x. Is this equivalent? How do you know? So when you look at the full terms, you have a 7x and a positive 7x, positive 7x, positive 1, positive 1. Those are the same. Okay? If your terms were a little bit different, it wouldn't work. Yes, it's an equivalent expression. The reasoning for that, he used the commutative property. It's the same terms, just in a different order. Okay? And only because that's addition is that allowed. If that had been subtraction, 7x minus 1 and 1 minus 7x, that wouldn't work. Okay? All right, and then Jill got 7x plus 1 and then wrote it as 1x plus 7. Is that the same? So you have a 7x and then you have a 1x. It's like having 7 students and 1 teacher. And this is like having 1 student and 7 teachers. It is not the same thing. So no, they are not. Because 7x does not equal 1x. And 1 does not equal 7. So they're not like terms. Okay? Alright, so that was it for your homework. That was homework 40. That was last night's homework, so you can put that away. Your due now can go in your due now section. And what you need to have out now is your lesson 1 through 6 packet, opened up to lesson 2. Alright, so this opening exercise they have is very basically similar, basically the same thing as what we did. We went through opposites, additive, inverses, and just proved that they're opposites. That's all. So it's just a quick refresher. So opposite is 7. The proof is just negative 7 plus 7 equals 0. Okay. 1/2, negative 1/2, 1/2 plus negative 1/2 equals 0. Okay. Now this is where it's a little tricky, a little different. We have x. So we did do x on the do now, which was negative x. Then you have 3x. So this is going to be the same thing. 3x, so negative 3x. So 3x plus negative 3x equals 0. Okay? That's when you want to be careful with. You have to negate both of them. So negative x plus negative 3. If you just do the x, you're completely ignoring that whole 3, which is not allowed. So x plus 3 plus negative x plus negative 3 is 0. And then here we have 3x minus 7. So we can do one of two things. We can do 3x plus 7 or negative 3x minus negative 7. Either one of those is actually going to be the same thing. Okay, so 3x minus 7, we'll do plus negative 3x plus 7 equals 0. All right, moving on. So we have to subtract. We have 40 plus 9 minus 30 plus 2. So the easy way, what they kind of want you to see here, the easy way to do a problem like this would be to kind of break it up. And do 40 plus 9 here, 30 minus 2, plus 2. Do 40 minus 30 and get 10. And then 9 minus 2. Get 7 and get 17 from there. Okay? They want you to see that because we're going to actually do the same kind of a thing with these here. So I'm going to write it over here so I have more room. 3x plus 5y minus 4. When you line up this second one here, you want to line it up with the right letter. So 4x is going to go under the 3x, and plus 11 is going to go under the minus 4. And then this is all being subtracted. Okay? So we have 3x minus 4x, which gives you negative 1x. 5y, well, there's nothing here. So it stays 5y. Then negative 4 minus 11. I'm going to write it on the side. Negative 4 minus 11. If you keep change, negative 4 plus negative 11, you're going to get a negative 15. So you can either write plus negative 15 or minus 15 there, and they're the same thing. Okay, so that's going to be more along the lines of what we're moving towards. You didn't have to do it this way. You could have actually distributed out this as a negative 1, said negative 4x plus negative 11, and then combine like terms from there. That would have been okay too. But this lining up option is pretty cool because it kind of lays everything out for you nicely. All right, so I'm not going to do C. I want you, example 2, I want you to do C. You're going to line them up vertically, meaning line them up just like here. Try it out. Have B check it. Remember, this one's addition, not subtraction. Okay. Next page. Okay. You have another one here. This one is subtraction. This is another one where you have a missing hole in it. So I will line it up for you here. But beyond that, you got to finish it. Okay, so 5x goes under here, plus 2 goes under here. All of it's being subtracted because there's subtraction here. Okay, so finish that up. And then you will see I crossed out 3 and then this beginning part of 4. We are going to get into word problems, just not today. Okay. So we're down here at 5. So this is very, very similar to what you had done yesterday, and therefore for homework last night. We just now have, whoops, sorry, I'm like losing my camera. We just now have some subtraction and some parentheses going on there. So I'm going to kind of be jumping around on the paper because there's not a lot of room on here. Okay, so if you want to use the room up here, that's probably going to be your best bet since we're not doing those problems. Okay, so I'm going to do G all the way on top here. Okay, so G is 4y minus 3 plus y. Okay, so we could have lined this up vertically like we did up there if we wanted to, or we can do that distributing of the negative part here. So 4y is going to stay. This negative, you can kind of treat it like a negative 1 and multiply that in. So negative 1 times 3 will give you a negative 3. Negative 1 times y gives you a negative y. Now that we did that, like terms, 4y plus negative y is 3y, and then plus negative 3 because nothing happened to it. Okay, they do want us to check this with a y equals 2. So you want to go back and plug 2 in. So 4 times 2 minus 3 plus 2. So everywhere you see a y is a 2. Okay, so this is 8 minus 3 plus 2 is 5. So this is 3. And then this one here, so this is the original 3 times 2 plus negative 3. So 3 times 2 is 6. 6 plus negative 3, also 3. So that does check out. So that is your answer for G. So that doesn't look like a G. Okay, next one I'm going to do is J. I'm going to do J right here. So D plus 3D minus negative D plus 2. So D plus 3D stays. We can actually just drop the set of parentheses here. Now, negative 1 times a negative D is going to give you a positive D. Negative 1 times a 2 gives you a negative 2. So now you have 1D, 3Ds, one more D here. Altogether, you have 5 Ds plus a negative 2. Okay, so we want to check that. So 5D, D they say is 3. So 5 times 3 is 15, plus negative 2 is 13. All right, now we have to check this big long one up here. So D plus 3D minus negative D plus 2. So all the D's are 3's. So it's again down here from the problem. 3 plus, well, that's 9, minus negative 3 plus 2. So 3 plus 9 minus negative 1. 3 plus 9 is 12. 12 minus negative 1 gives you 13, because you keep change. So that checks. And again, this is our answer here. Okay, so I did G and J. G, the answer was 3y plus negative 3. J, the answer was 5d plus negative 2. Okay, so this 13 that we got here, that was our check. That was not our answer. That is us making sure that our answer is correct. So make sure you are understanding that, okay? We're going to jump to L. I'm going to do L just right below here, okay? So I know you're going to not have any more room after these couple problems. Take out a sheet of paper. Staple it in, tape it in, something. Don't lose it, but take out a sheet of paper. I apologize for not giving you more room on this one. I didn't realize it was so small. Okay, so 11f minus negative 2f plus 2. That's what we're doing. We're doing L. Okay, 11f, when we distribute out this negative 1, negative 1 times negative 2 is positive 2f. And then you have a negative 1 times a positive 2, so plus a negative 2. So you have 11f plus 2f, so 13f plus negative 2. Okay. So we want to check them. F is 1/2. So half of 13 is actually 6.5. You can use your calculator for that though, no problem there. And then plus negative 2, so it's going to be a positive 4.5. So that's one of our checks. Our other check is going to be using this original. So 11 times f, just 1/2, minus negative 2 times f, whoops, plus 2. I said whoops because I'm running out of room on that paper there. Okay. 11 times 1/2 is 5.5. Negative 2 times 1/2, that's a negative 1. Okay, negative 1. Do parentheses next. Negative 1 plus 2 is 1. So 5 minus 1, 4.5. It checks. This 13f plus negative 2 is your answer. All right, one last one. And then we have the next page. But besides the point. So 2g plus 9h. Actually, no. We're not doing that. You're not doing that. It's gone. So next page. So this one, we're going to be talking about the multiplicative inverse. Okay, it's a funky word to say. Multiplicative. Kind of like saying multiply, multiplicative. The inverse of multiplication. Okay, so multiplicative inverses always have a product of 1. So the multiplicative inverse is always going to be flipping it. So this is 3 over 1. So the multiplicative inverse is 1 over 3. Okay, so additive inverse, you change the sign. And multiplicative inverse, you flip the fraction. So it's like the flip when we keep change flip. It's our flip. Okay, so 5 over 1, so 1/5. Proof, 5 times 1/5 is 1. So for a problem here, 65 divided by 5, we can keep, change the multiplication, flip it over. Okay. So 65 over 5, so you get 13. Okay. So this one, negative 2 over 1, is going to be 1 over negative 2. Okay. This is the same thing as just negative 1/2. We don't really write 1 over negative 2, but that negative can be technically put anywhere in that fraction and be equal. Okay. Our proof, -2 times -1/2, it equals 1. I'm not going to go out through proving why it equals 1. It just does. We're good, okay? So keep, change the multiplication, flip to the fraction, okay? 18 times 1/2 is 9. This is spun rules, unlike signs, negative. Told you, these aren't going away, okay? So here, keep, change, flip. So we're flipping it. 5/3, negative stays out front. Multiplying them together, you get 1. Okay, so keep 6, change the multiplication, flip this over. Okay, 6 goes over 1, so -30/3, so -10. X over 1, 1 over x. We don't know what x is, and that's okay. Okay, so 5x times 1 over x. Okay, so end up with 5x over x. X divided by x is 1, so they actually cancel, and you just get 5. All right, and then 2x over 1, so 1 over 2x. So 2x over 1 times 1 over 2x, get 1. So keep, change the multiplication, flip it over. So 12x over 2x, x's cancel, 12 divided by 2 is 6. All right, last page of this packet, I'm going to do 3 problems with you, and then you're going to go back and work on anything that you haven't done already. Okay, so we're writing expressions here. So expressions, remember, no equal sign. Expressions are written with numbers and symbols, mathematical expressions, okay? Sum is always going to be addition. Difference is subtraction. You could say subtracted from. That means you actually have to switch the order, okay? Because if I say Peter is subtracted from Miss Scanlon's class, it's Miss Scanlon's class minus Peter, not the other way around, okay? So find the sum of -3x and 8x. So sum means we're adding, okay? So this is how you write that expression, -3x plus 8x. They want your answer in standard form. Standard form means simplest. It means you can't combine any like terms. You can't do anything else more to it, okay? So we just have -3 plus 8 is what we're doing here, okay? And that gives you 5, and then you keep your x. That's all. Okay, so see, find the difference when 6h is subtracted from 2h minus 4. So 2h minus 4 is first, and then you're subtracting 6h. Okay, so here, you might want to box things in. So 2h minus 6h is going to give you a -4h. And then we keep our -4. That's done. No like terms. Can't get it down any smaller. It is done. All right, and then G, taken away from. So -7x plus 2, and then minus -2x plus 9. So notice how I put that second term that I wrote in parentheses, because we're subtracting. So we're going to have to change all the signs in that last set of numbers here. So this is like a -1, so this stays identical. We're going to distribute out this minus. So minus or negative times a negative, it's going to be same signs positive. So plus 2x. Okay? -1 times positive 9 is going to give you a -9. Okay? And then we do our like terms. So -7x plus 2x, -5x. If you need to use a calculator, you can, but you got to remember those rules. This is your song. Same signs add and keep, different signs subtract. Okay? So that was different signs subtract. Keep the sign of a larger number. Things will be exact. Okay, I had to finish it. Plus 2 plus -9 is going to give you a -7. this can actually be written as -7. Those are equal. Was it equal? I was going to write equivalent, but I forgot how to spell it. So yeah, those are equal. Okay, we were going to do 12, but we're going to hold off on that. We'll do all the words problems together. So at this point, I am done with this video. I know it's the longest one yet. But you are going to go back and finish anything from the last 4 pages that you haven't done already. Call me over, have me check over your stuff. Maybe if you have some extra time, you can work on your homework. We'll see. Talk to me if that is the case, all right? So go ahead and get to work.